Hello class. In this video, we cover section 3.3. We are going to learn a very important concept, truth table. This section covers truth tables for negation, conjunction, and disjunction. Remember the symbols for those logical relationships. What do we use if we want to negate a statement? We put a with in front of the statement, right? Conjunction. If we place this notation, this symbol, between two component statements, we have a conjunction. And disjunction is the right side up V between two component statements. All right, what is truth values? Truth tables describe the truth values of statements. And truth values, any statement has one of the two truth values, either true or false. True or false. We use T to represent truth. F represents false. The objective of this section is to use the definitions of negations, conjunction, and disjunction to construct truth tables and determine the truth value of a given compound statement for a specific case. Truth value refers to T or F. To be a statement, the sentence can only be true or false, cannot be both simultaneously. Remember that? Okay, so the first truth table, you need to remember this. You need to memorize. Spend time and effort to memorize. We have 1, 2, 3, 4, 5. We have 5 basic truth tables that you need to spend time and effort to memorize them. This is the first one. Okay, this is the first one. Negation, truth table for negation. It's pretty straightforward. Given statement P, given a simple statement P, P could only has one truth value, right? It's either T or F. So below P, we have T and F. So this is the case 1. In the truth table, we have case 1. This is the case 1. This is the case 2. 2 cases. We have 2 cases for the truth values of P. It is either true or false. When P is true, then the negation of P is false. When P is false, then the negation of P is truth. When two statements are negations of each other, then they have opposite truth values. Does that make sense? If we say P is, let's say, London is the capital city of England, we know it's true, right? Then not P would represent the statement that London is not the capital city of England. So it is false. It's against the fact. Yeah. So the first truth table is pretty straightforward. All you need to remember is the negation has opposite truth values. Not the P changes the truth value from true to false or false to true. So that's the first one, pretty straightforward. The second truth table, let me erase those. Let me see if it doesn't let me. Okay. So that's the first one. Very important. And the second one is the truth table for conjunction and statement conjunction. One sentence you must remember is, for a conjunction to be true, both of the two component statements have to be true. That means in order for P and Q to be true, both P and Q must be true. Even just one of them is false, then the conjunction is false. To make it simple, I would recommend you remember this sentence. Let me state it again. In order for a conjunction to be true, both of the two component statements have to be true. In order for P and Q to be true, both P and Q have to be true. Both P and Q have to be true, right? Does that make any sense? Because this compound statement states P and Q, right? Both. They happen simultaneously. Then in order for the conjunction and to be true, of course, both of them have to be true, right? If one of them is false, then the conjunction is false. So since we have two component statements, we have four cases. Case 1, 2, 3, 4. Because P could be true or false, so two possibilities. Q could be true or false, two possibilities. By the fundamental counting principle, 2 times 2 is 4. That's how do we know we have four cases. Yeah. So please always follow the order of the four cases. Always follow the order of the four cases. What are the order that I'm talking about? Always go with TT, TF, FT, FF. Okay? Yeah, always follow the order. If we consider two simple statements, if the compound statement only contains two simple statements, then the first two columns of the truth table must describe the four cases. The first case must be TT, second case must be TF, third case must be FT, and the fourth case must be FF. So please follow the order. Okay, so remember, for a conjunction to be true, both of them have to be true. So that's how do we have the truth value for P and Q in the last column. Only in the first case, when both P and Q are true, when both P and Q are true, we have P and Q to be true. And all other three cases, they are false, right? They are false. Okay, so that's truth table for a conjunction, P and Q. You need to memorize this one and understand. Memorize the sentence. In order for a conjunction to be true, both of the two component statements must be true. In order for P and Q to be true, both P and Q have to be true. If one of them is false, then the conjunction is false. Next, disjunction. Or statement, right? Okay, you need to remember this sentence. For a disjunction to be false, both of them have to be false. For a disjunction P or Q. So now we are talking about disjunction P or Q. For a disjunction P or Q to be false, both P and Q have to be false. If any one of the two component statements is true, then the disjunction is true. We do not need both of them to be true to make the disjunction to be true. At least one is true, then the disjunction is true. So look at the table here, the last column. When both of P and Q are true, disjunction is true. When P is true, even Q is false, or Q is true, even P is false. Yeah, one of the two component statements is true, then the disjunction is still true because we are talking about or, right? Or P or Q. For P or Q to be true, at least one of them is true, is enough, is sufficient. Yeah. To make it simple for us, you want to remember the only case that the disjunction is false. It is the last case. To make a disjunction to be false, both of the two component statements have to be false. It's just a way, an easy way to understand and memorize the truth table for disjunction. Okay, let me repeat that. For a disjunction to be false, both component statements must be false. In the truth table, there's only one case in which the disjunction is false. That is when both components are false. And you also should understand, for a disjunction to be true, at least one component is true, is sufficient, is enough. Okay, so those are the three basic truth tables. Very, very important, very basic and important. You will see a lot challenging questions in MATLAB Math. But you know what? They're all based on those tables, the basic truth tables. This is for negation. This is for conjunction. This is for disjunction. As long as you understand those basic truth tables, of course, next section we're going to learn the truth tables for conditional and biconditional. Altogether, those 5 basic truth tables are enough for you to solve all the problems in MATLAB Math. Even they do look very challenging, but the important thing is you understand those basic. Okay, so let's practice. Let's apply what we have just learned. Yeah, the truth values for negation, conjunction, and disjunction. Okay. This example, we have 2 statements are given. 2 simple statements are given. P is the statement that 3 plus 5 is 8. You tell me true or false. Of course, it's true, right? 3 plus 5 is 8. Q is the statement that 2 times 7 is 20. That definitely is false, right? 2 times 7 is 14, not 20. Okay, so we have 2 simple statements are given, P and Q. P is true, Q is false. We need to determine the truth value for the following compound statement. First one. The first one is a conjunction or disjunction. Yeah, at this point, you should be very familiar with those symbols, right? We learned the symbols yesterday. This is and, P and Q. It is a conjunction. Okay, remember, for a conjunction to be true, both of them have to be true. Do we have both P and Q are true here? No, we don't, right? Yeah, Q is false. So we do not have both components are true. So that makes this statement false. Second, the second one is also a conjunction, all right? Yeah, it is a conjunction of 2 pieces or 2 components. The first component is P. The second component is not Q, all right? So let me color them. We have 2 components. First component is P. Second component is not Q. We are taking the conjunction of those 2 components. So we need to know the truth value for the 2 components, right? All right. P is true. We know that is given. Q is false, but not Q is what? If Q is false, then the negation of Q should be true, right? Because when you negate a statement, you change a true statement to a false and change a false statement to true. You got the opposite truth value. Okay, so that means the 2 components in this conjunction are both true. That makes the conjunction to be true. Because for a conjunction to be true, we need both component statements to be true, right? And both 2 components are true. So number 2, the statement, common statement, it is true. Number 3. Number 3 is a disjunction. We have 2 components. The first component is not P. The second component is Q. Let me color them. So number 3, the compound statement is a disjunction, or. And the two component statements in a disjunction are not P and Q. So let's find out the truth values for those two components. P is true, so not P is false, right? Q is false. All right, so can you help me to figure out what's the disjunction of the two pieces, of the two components? Remember, for a disjunction to be false, both of the two component statements must be false. This is false. This disjunction is false because both because both of the two component statements are false. All right. Number four, this compound statement is a disjunction as well. Two components. The first component statement is not P. Second component statement is not Q. Let's color this is the first component, this is the second component. We're taking the disjunction of the two components. And we need to figure out the truth values for the two components. P is true, not P would be false. I'm showing you the right way to solve this kind of problems, and you should do the same thing. Yeah, P is true, then not P is false. Q is false, then not Q is true. Q is false, then not Q is false. Is true. Yeah, it's opposite, and that makes the disjunction to be what? To be true. Because for a disjunction to be true, we do not need both of them to be true. At least one is true. That is sufficient. Okay. Does that make sense? Next example. Truth tables can be used to gain a better understanding of English statements. Complete the truth table for the given statement. The given statement is a disjunction. Okay, disjunction. It has two component statements, not P and Q. All right. So when you construct a truth table for a given compound statement, I always start from the last column. I'm sorry. Of course, you have to figure out how many simple statements do you have. In this case, we have two simple statements, right? So the first two columns must be PQ, and then follow with the four cases, TT, TF, FT, FF, always like that. And then I start from the last column. The last column is your target compound statement, your target compound statement. Okay, so this is how do I do it. I don't mind to make a new table here. So this compound statement has two simple statements, only contain two simple statements, P and Q. So I know I'm gonna have four cases. Case 1, 2, 3, 4. And the four cases are true, 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 false, false, true, false, false. Okay. And then I'm going to start my last column in the truth table is going to be my target statement. What is my target statement? Is the given compound statement. It is not P or Q. I know it's a disjunction, right? It is a disjunction. And then the disjunction has two pieces, has two components. The first component is not P. The second component is Q. All right, the two component. The first component is not P. Second component is Q. I put the two component statements right in front of my target statement, compound statement. And you might wonder, this is different from the book here, right? The note here. And because Q is already appear in the second column, sometimes they don't copy it, but I don't mind to copy it because this is more convenient for me to think. All right, so in order to know the truth value for the disjunction, this is a disjunction. I need to know the truth values of the two components, right? Yeah, this is the first component here, this is second component here. I'm going to fill in the blanks for both two components. When P is true, not P is false. When P is true, not P is false. When P is false, not P is true. It's opposite, right? When P is false, then the negation of P is true. So that's the third column, the first component of the disjunction. The next column, exactly the same with the second column, right? So you just copy it. It doesn't take you too much time, but I would do that because it helps me to think. Is more organized. For me, this way is more organized. I have the two components right in front of my target. My target is a disjunction, so the truth value of the disjunction depends on the truth value of the two component statements. Okay, remember, for a disjunction to be false, only when the two components to be false, right? Yeah. For a disjunction to be false, both of the two components, the yellow, have to be false. So only when the second case, 4 cases, 1, 2, 3, 4. Yeah. The second case, yeah, the second case, we have the disjunction to be false. Only in the second case, both of the two components are false. So that makes my disjunction to be false. And all other 3 cases, the disjunction are all true. So that is the truth table that I made for this target compound statement. And you should do the same thing, okay? Yeah, you should do the same thing. Let's continue. And okay, this is a negation. Yeah. So this question, we are going to construct the truth table for a negation. Negation of what? Negation of this one, right? Yeah. So the last, so this compound statement also only contain 2 simple statements. That's how do we know we have 4 cases only. And again, follow the order of the 4 cases. Same with this order, T, 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 F, F, T, F, F. Okay. And the last column in this table, we have the target compound is a negation. Negation of what? Negation of the statement right in front of it. Yeah, this is a good structure. Yeah, in front of it. And how do we know the statement of this statement, compound statement, is a conjunction, right? And in order to know that, we need to know the 2 pieces. What pieces? What are the 2 components of this conjunction? P and not Q, right? Yeah, that's why we have an extra column. We need to know the truth value for not Q. So P and not Q, those are the 2 component statements of this conjunction. Yeah, we need to figure out the truth value for the conjunction first, because our target compound statement is just a negation of that conjunction. At this point, you should be able to see the structure of the compound statement. And you must do that because otherwise it's not possible for you to have the correct truth tables. All right, so let's see what's the truth value for not Q. Q is in front of Q, not Q, right? Yeah, not Q and Q should have opposite truth values. When Q is T, not Q is false. When Q is false, not Q is true. When Q is true, not Q is false. When Q is false, not Q is true. Okay? So now look at the 2 yellows. The 2 yellows are the 2 components of this conjunction. What's the sentence that you need to memorize for a conjunction? For a conjunction to be true, both of the 2 component statements must be true. Okay, do we have that? Do we have that? Both of them have to be true. Okay, here we go. For a conjunction to be true, both of the two components must be true, right? Yes, in case 2, both the two components are true. And in all other 3 cases, we don't have both of them are true. So that is false, false, false. So far so good? Okay. And then conjunction is a component of our target statement. Our target statement is the negation of the conjunction. Okay, so to negate, false becomes true, true becomes false, false becomes true, false becomes true. And that is the truth value. That's the truth tables for our target compound statement. Yeah, the compound statement that is given. How do I understand that? When P and Q both true, our compound statement is true. When P is true, Q is false, our compound statement is false. When P is false, Q is true, our compound statement is true. When P is false, Q is false, our compound statement is still true. Okay? Yeah. So the truth values for the compound statement in all the 4 cases. Next, look at the structure. This kind of questions requires you see the structure of the compound statement very clearly. It is a what? It is a disjunction. Okay, it is a disjunction. It is disjunction. And the two component. The first component is P. The first component is P. The second component is not Q and R. Those are the two components of the compound. Okay. Yeah. Okay, so you might wonder, this table has 8 cases. Why do we have 8 cases in this table? Because this compound statement, our target compound statement, contains 3 simple statements, P, Q, R. Okay, P could be true or false, so 2 cases. Q could be true or false, 2 cases. R could be true or false, 2 cases. By the fundamental counting principle, 2 times 2 times 2, we have 8 different cases. That's how do we have 8 cases. All right. So if your target compound statement contains 3 simple statements, then the first 3 columns is going to be PQR, followed with the 8 cases. Yeah. Let me show you the order of the 8 cases. What's the benefit of following the same order? If following the same order, then you won't mess up. Like you will not have 2 cases, they are the same, or you are missing 1 case, right? It's very organized. Let me show you. So the first 4 cases, P is true. The last 4 cases, P is false. Suppose P is true. For Q and R, we have 4 cases, right? T, 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 F, F, T, F, F. When P is false, Q and R also have 4 cases, T, 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 F, F, T, F, F. That's how do we write the 8 cases in this order. Yeah, it's good to follow the same order. And that's the basic structure of this truth table. Okay? As I explained earlier, the target compound statement is a disjunction. It is a disjunction. And the 2 components are the 2 yellows. Okay, are the 2 yellows. The first component is very simple, it's just a P. The second component is a conjunction. Yeah, the second component itself is a compound. And the first, for the conjunction, the first component is not Q, and the second component is R. That's how do we have, if I do the table, I would have more columns. Even I would repeat the columns. But this is good too. Yeah, depends on your preference. So I have my notation here. Yeah, how about I box them? I box the two components in red box. So this one and this one. Yeah, those are the two components for this conjunction. All right. Yeah, one step at a time. Yeah, let's figure out the truth value for the second component of the target statement, which is a disjunction. And we need to figure out the not Q. We need to figure out the not Q. Need to do this. Okay. Look at the Q here. When Q is T, not Q is false. When Q is T, not Q is false. So just take the opposite. When Q is F, not Q is T. When Q is F, not Q is T. When Q is T, not Q is F. Be careful. Yeah, if you mess up one, the system will not let you continue. You have to figure it out. So when Q is T, this is F. Q is F, now Q is T. Q is F, now Q is T. Let me double check. So make sure those two columns have opposite values, truth values. TF, TF, FT, FT, TF, TF, FT, FT. Okay, that's correct. Don't be afraid to double check. You should always make sure that the current step is correct. And now we are ready to find the truth value for the conjunction here. All right, truth value for that conjunction. What's the sentence I made you to memorize for the conjunction? For the conjunction to be true, both pieces have to be true, right? Yeah, the red boxes, those are the two pieces. They happen to they happen to be right in front of the yellow, not Q and R. Yeah, for the conjunction to be true, both of them have to be true. Yeah, this one, case 3, both of them are true. Case 7, both of them are true, right? And that's the only two cases in which both of the two components are true. So it means all other 6 cases, the conjunction is false. This is a false, 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 and this is false. Okay, so now we are ready to find the truth values for our target statement. Our target statement is a disjunction. Is the two yellows? Are the two yellows? Yeah, the first column and this column. Those are the two components for the disjunction. Disjunction. Remember the sentence for disjunction. For a disjunction to be false, both of them have to be false. All right, let's look at the two yellow columns. In which cases both of them are false? This one. And this one. And this one. Let me double check. So case 1, they are not both false. Case 2, they are not both false. Case 3, they are not both false. Case 4, they are not both false. Case 5, they are both false, so the disjunction is false. Case 6, they are both false, so the disjunction is false. Case 7, they are not both false, so it's true. Case 8, they are both false, so it's false. And that's the truth table for this compound statement. Yeah, it has 3. It contains 3 simple statements. Okay. A truth table shows the truth values of a compound statement for every possible case. In our next example, we will determine the truth value of a compound statement for a specific case in which the truth values of the simple statements are given. This does not require constructing an entire truth table. Okay? Determine the truth value for the statement when P is false. P is false. Q is true. R is false. All right. Even we don't need to construct the truth table, we still need to see the structure. Super important. Okay, I repeatedly emphasize how important it is to see the structure of the algebraic expressions. This is a logical expression. It's like if you are a doctor or nurse, it is very important to see the anatomy, right? If you are an architect, it's very important to see the structure of the buildings. Same with us, we learn algebra. It is very important to see the structure of a given expression. And look at this one. This is a what? The structure. This is a disjunction. This is a disjunction, okay? This is a disjunction. Disjunction. And the disjunction has two components. You should do what I do. The first component is this. And second component is this negation. Yeah, you must be able to see our target statement is a disjunction. The disjunction has two component statements. This yellow and this yellow. Okay. And the disjunction, the truth value of the disjunction depends on the truth values of the two components. Let's figure out the truth value for the component. All right. Yeah. P is false. Q is true. Yeah. So P is false, Q is true. So P and Q is false, right? Because P and Q is a conjunction. For a conjunction to be true, both of them have to be true, but P is false, so P and Q is false. Yeah, P and Q is false. Then the negation of P and Q would be true. Do you see that? Do you agree? Yeah, P is false. That makes the conjunction to be false. And you negate that conjunction, you have a true statement. And next component, let's figure out the truth value for P or R. Okay, it's a disjunction. P is false, R is false. Both of them are false. For a disjunction to be false, both of them need to be false, right? Yeah, P is false, R is false. So P or Q is false. P or R is false. Yeah, P is false, R is false. So P or R is false. And the negation of that is true. Okay, so we have both. We have the truth values of two components taken care of. Then what is the disjunction of the? What's the disjunction of the two components? It must be true, right? Yeah, disjunction, because both of them are true. Even just one is true, that is sufficient for the disjunction to be true. Not alone. This both of the components are true. Let me double check. P is false, Q is true, so that is false. Negation is true. And P is false, R is false, disjunction is false, negation is true. Both of them are true. Of course, the disjunction is true. Yeah, your answer is true. You did not do the dishes, but you did not leave the room a mess. So for this example, we are going to write a statement in symbolic form. Assign letters to simple statements that are not negated. Okay, so here, I'm going to let P, yeah, we use PQR, right? We are going to let P to represent this statement. You did the dishes. You did the dishes. And Q, you left the room a mess, because the question requires us to use a simple statement that is not negated. Yeah, so Q is gonna be you left the room a mess. Okay. Then the given sentence, you did not do the dishes, but you did, but remember, but also means conjunction, right? Yeah. But, and, yet, or nevertheless. Same thing. It's in the table we worked on yesterday. You did not leave the room a mess. So symbolically, not P and not Q represent the given sentence, the statement stated in English. And we need fill in the truth table, right? Yeah, because the target statement involves two simple statements. We have two cases for P and Q. TT, TF, FF, FT, and FF. And the two component. Yeah, when you look at me solve those problems, you should know the right way to solve the same type of problems, and you should do the same thing. Please do not be creative or stubborn. I just do whatever I want to. I don't care if the teacher used the method. And what's the reason you are taking the class, right? You have a teacher, the teacher is willing to spend time to make those videos and show you the right way to do the problems, and you should watch the video and learn, right? Okay, the two components, not P and not Q. Let's see the values for those two components. When P is T, not P is false. Yeah, so P, not P. So T, F, F, T, F, T. Yeah, this one should have opposite values. Okay, and then we do not Q. Look at the column 2. TF, FT, TF, FT. Yeah, this column and this column, they should have opposite truth values because they are negation. Okay, now we are ready to find the truth values of the target statement, the common statement. It is a conjunction and, okay? And. What's the sentence you must remember for the truth value of a conjunction? For a conjunction to be true, both of them have to be true. For a conjunction to be true, both of them have to be true, okay? The 4 cases, only the last case, case 4, we have both of the two components are true. All other F, 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 okay? Use the truth table to indicate one set of conditions that make the compound statement true. And the last one, this case. Oh, where did it go? Yeah. So the last one, when both P and Q are false, the compound is true. Okay? Yeah. And that's everything about this section. It's very, very important. I hope you really spend time to watch this video. If you have any questions, please feel free to email me. I'll see you in the next section.